Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 3474, lexicographically smallest generated string. The problem asks us to reconstruct a string of minimum length given two constraints represented by string 1 and string 2. We are given string 1 consisting of t's and f's, and a pattern string 2. A t means the substring starting at that index must match the pattern exactly. An f means it must not match. Our goal is to find the lexicographically smallest string satisfying these rules. Let's dive into our thought process. The core idea is to use a greedy depth-first search approach. Because we want the lexicographically smallest string, we must make decisions from left to right. Our state space involves the indices of the question marks. For each question mark, we greedily try characters from A to Z. Here is a visual dry run. Imagine we are at a question mark. Our greedy strategy tells us to first try adding the letter A. We place it in the string and then we must validate this choice against our rules. We need to ensure that placing this A does not accidentally create a substring that matches string 2 where an F constraint exists. What happens if our choice is invalid? Suppose we place an A, but our validation check hits an F constraint. This means our current path is invalid. In this case, we backtrack. We undo the choice of A, and move on to try the next character, B. This recursive backtracking continues until we find a valid configuration for the entire string. At index 1 deciding what to place, and index 0 is already A, placing B at index 1 would complete the forbidden word AB. Our DFS must recognize this, mark B as forbidden, and skip it. Now let's look at the implementation. First, we need a way to validate our choices. We build logic to check for forbidden characters. For a given index, before placing a character, we iterate through all F constraints that overlap with this index. If placing a character would complete a forbidden pattern, we mark that character as forbidden and skip it. 2. With validation in place, here is the main recursive DFS function. It takes the current index and tries to place a valid character. For each character from A to Z, if it's not forbidden, we place it and recursively call DFS for the next question mark. If that deeper call returns true, we are done. If false, we backtrack by resetting the question mark. If this deeper call succeeds, it bubbles all the way up, and we are done. But, if it returns false, we hit the backtrack step, we revert word, I, back to a question mark. This undoes our choice so we can try the next letter in the loop. Because we always iterate from A to Z, the first complete valid string we find is guaranteed to be the lexicographically smallest. The time complexity is O of n times m in the worst case, but pruning makes it incredibly fast. The space complexity is O of n for the recursive call stack. Thank you for watching, and see you next time.